Alright guys, this is another day that the Lord has made. We should rejoice, we should be glad with it. So welcome, today we are going to study details about the alternator, and this comes as a result of the demand from the other video that I did about the charging system. So this one we are going to study details about the alternator and how it functions. So now this is a Mazda car alternator. If you look at it, it's a 5-wire alternator. We have our main wire. This is we call it a B positive terminal. This is the one that connects this alternator with the battery via the main fuse. Yeah? Then we have this connector. This is a 4-wire connector, but we are going to study details about it when we open this alternator. But for me, this alternator, I call it 6-wire alternator, simply because of the ground. This body of this alternator, it passes the ground. It is mounted tightly on the engine of the car, whereby it creates a network of the ground with the rest of the vehicle chassis. So now what we are going to do, we are going to open this alternator. And to open this alternator, we start with these nuts. We open these ones very fast. I will remove this top cover. Very careful. Then this one I had opened it earlier to make my work easier. Then when you look at this, this is our regulator, but most people call it cut-off, but it is our regulator. So guys, this is our regulator, and this regulator, it is controlled by the computer. So in this regulator, we have 4 wires. We have the 4 wires. If you can look at this connector. So what happened, the first wire is the light wire. It receives current via the battery light on our dashboard to the regulator. So what happened, when this alternator starts to produce voltage, which is higher than the voltage that come in via this wire, due to potential imbalances, it cancels out the voltage on this, and then our light on the dash, our battery light on the dash goes off. Then the second wire, it's the ignition wire. This ignition wire, when you put on the ignition, we receive current via this wire. Then it goes through the regulator to our brushes, to our slip rings. This is our slip rings. When you remove these brushes, you can see this is our slip rings. Then to our rotor. Right. Then you also have another wire, the sensor wire. This sensor wire, it is the one which sends information to the computer. It tells this computer the performance of this alternator, how this alternator is performing. Then you also have another wire. This is it's a field regulator. This one usually sends frequencies from the computer. The computer receives information from other computers, like the BCM, to know how much voltage this alternator is producing and how much voltage which is needed in the car. So then the computer sends frequencies to control this regulator, to tell this regulator, oh, we need more load, then produce high voltage. We need less load, then produce low voltage. This regulator, if you want to know when it has a problem, most of the time, it usually gives an overcharge. When you test the voltage from your car and you realize that it is producing voltage which is about 15.2 volts or 15.5 volts, then that one definitely tells you that this person is sick. Because it's the work of this person to regulate the amount of the voltage that is coming from the alternator. Our current goes through the regulator to our brushes. And the current that comes to these brushes, it's already regulated. It's already to our rotor. This is our rotor. So let's remove this rotor. This is our rectifier diode. It's a bridge rectifier diodes. bearings. Remove this one. This one is okay. Then we have our bearing. This is our bearing. So what we do, take our hammer. Hammer it carefully. It's out now. This is our rotor. It's already out. This is our stator. Have a look at it. So guys, this is our rotor. What happened to this rotor? It received current by these slip rings. You see these slip rings? Then when it received voltage, it creates magnetism in these windings. So we usually have the north pole and the south pole on the other side, but they usually alternate. When you rotate, those poles changes. So now, when you want to know that whether this rotor is okay, what happened? We always test the continuity. So we take our multimeter. You take your multimeter, this one, you position it at the continuity. Hold it there carefully. Then you take the other side, you position it there. You can hear the hissing noise. That one tells you that there is continuity. This one is with the body, there is no continuity. So that one is how we test this rotor. So for this one is okay. So now, the next thing that we are going to do, we want to study this, we call him a stator. And this stator, as you can have a look on it, we have our bearing here. This bearing, this bearing is okay. So now, this is a winding. Because if you have a look on it, we have this face, we also have this face, we also have this face. But this is a common. It's a common. When this one is electromagnetized, it rotates across this winding. So what happened? It induces an EMF across these windings to give us an alternating current. So we have three phases of alternating current. For this guy, this one, and this one, and this one, they gave us a three-phase. So here, we have this gadget. This one, we call it it's a bridge rectifier diode. So now the work of this guy, because in a motor vehicle, we don't need an AC. So what happened? This guy is the one that usually converts the AC which is produced by this guy to DC. So in this rectifier diode, we have 6 diodes, because as you can see, we have 3 phases. This phase, and this phase. And in every phase, we have 2 diodes, which are used to give us the. So now, we want to test this woman. What we do, we only test the continuity. You test the continuity of this phase and the common. You also test this one with the common. You also test this one with the common. Let's have a look. Check a reading. It's reading. So that one tells us that this phase, it is complete. It has a continuity. Let's have another phase. Yes, this phase and this common. Good guys, you see? But you can send your comments. Other phase. Yeah, now let's test this phase and the common. You see, guys? Then this woman is a converter. The one which converts our AC to DC. So as we said earlier, this is a heavy duty cable that we connect it to the battery, but via the main fuse. So, because here we have 3 phase, these 3 phase, they are converted. So what happened? In each phase, we have 2 diodes. So now, if you have a look, we have this phase, this one, and in each phase, we have 2 diodes. So what we do, to check the performance, or to check whether this guy is okay, we test the diodes. And these diodes, they are one way. They only allow current to go in one direction, but that current cannot go in the opposite direction. So we can check. Let's check. This is the black one. Hold it here. Let's take the opposite direction. You see, when you take reading in that direction, there is no readings. Then when you take this one there, there is readings. Let's try here. There is readings. Let's take the opposite direction. There is no readings. So that one tells us that this diode is okay. So that's how you test diode. Alternatively, I want us to use this car. We test the performance. Something else that we can test this diode, we can check the AC, the amount of AC that is coming from the alternator. This alternator, we are usually given a range of a maximum of 50 millivolts. That's the amount of the voltage, the AC voltage that is supposed to come out from this alternator. So now we can use this car. We check our AC voltage. It should not exceed 50 millivolts. We have fixed our alternator. We have fixed, it's okay. So now we want to check the performance of the rectifier diodes by measuring the amount of AC that they are producing. As I said earlier, it should not produce anything above 50 millivolts. So now let's take our meters and take the measurement of the voltage, the AC voltage that is coming out from this car. To crank this engine and take our readings. Okay. What is it reading? It is giving us 14.6. Now this one tells us that this car is charging. Because when it is charging, this alternator it should give us 13.5 volts to 14.9, but it should not exceed 15.2 volts. So now, what we wanted to do, we wanted to check the performance of our rectifier diodes. So we said that for rectifier diode which is performing efficiently, it should not give you anything above 50 millivolts. But now the AC volts. So now let's take our readings to AC volts. You see now we have taken to AC volts and it is giving us 30 millivolts. So 30 millivolts, it's okay because our range was 50 millivolts. It should not give us anything above 50 millivolts. Because if it gives us anything above 50 millivolts, we will have a tendency of destroying some of the electronic gadgets in our car. Thank you guys.